Hello and welcome to Tonight at 8 from the RSGB. There can be no better feeling than hearing other radio amateurs on a receiver which you've built yourself. The feeling is even more magical if, as well as using conventional electronic components, you can also make use of some everyday items from around the house to not only make it original but make it perform better too. This is just what Nick Wood, M0NTV, has done, and he's going to share his ideas and design for a 40-metre radio with us tonight. So welcome to Tonight at 8, Nick. Can you give us a quick overview of what you'll be covering about this evening?
Yeah, thank you very much. Well, thank you for having me, and thanks for the invitation to speak. We're going to be looking today at building your own SSB receiver, one of the most basic SSB receivers that you can build, which is a direct conversion receiver. And this one is going to use all analog components and all discrete components as well. So there won't be any microcontrollers or anything like that. So it's all stuff which is doable, and it's all modular. So it's all going to be broken down into little bits that you can do perhaps over an evening or a weekend and put it all together and hopefully get something that will enable you to listen to, in this case, 40 meters. And what's unusual about this is that we're going to be delving into a different way of tuning. So rather than having a variable capacitor, we're going to have a variable inductor. And this one's a bit unusual, but we'll get to that in a minute.
I think the clue's in the title. Anyway, we'll look forward to it, Nick. If you're watching this on Monday the 7th of April, then this is live. And you can ask questions or make comments on either YouTube chat or BATC messaging at any time during the presentation or straight afterwards. Please include your first name and call sign if you have one within every message. And note that you can make this video stream fill your screen on most devices, usually by double-clicking on the picture or pressing the full screen button. So now let's go back to Nick to find out more about his homemade receiver.
Well, thank you. So yeah, I call this 40 meters on a glue stick. We'll get to the glue stick. That's coming up. But first of all, I just wanted to start with some basics, which is to say, it's possible to argue that all analog radios are essentially just different combinations of four basic building blocks. Well, what are those building blocks? Well, they are filters, mixers, oscillators, and amplifiers. Now these, of course, are very wide generic terms. There's all kinds of different filters and mixers and oscillators and all kinds of different amplifiers. But, you know, humour me, really you could argue they're all different flavours of these same four different types. And actually, once you've mastered these four different building blocks, you can string them together and build all kinds of radios. And complex radios are very often just more of these modules and different flavours of these modules put together. Now, there is a radio which is about as basic as you can get for listening to single sideband, and that is a direct conversion receiver. Because a direct conversion receiver consists just of one of each of those building blocks. So we have an antenna which is going to receive our signal. That's going to go through our band pass filter, and in our case it's going to be a 40 meter band pass filter, and then that band pass filter will feed into our product detector, which is just a mixer. It's just a mixer which is mixing down to baseband, to audio. And a mixer is a 3-port device. It has 2 inputs and 1 output. So one of the inputs is your signal, your 40 meter signal, which has come from the bandpass filter, and then the other comes from your oscillator. This is your local oscillator, so you're generating a signal which is going to mix with the signal that you're interested in to create a signal at a different frequency. And we will then use that, and we're only going to want one particular frequency, which will be an audio frequency, which we will put into an audio amplifier, and then squirt out, technical term, to our loudspeaker. So that is it, and that's about as basic as it gets. Now, a question I'd be fascinated to know the answer to, but it is not actually how many of you have built a direct conversion receiver. And it's very topical at the moment because Bill Mara and Dean Souls from the Solder Smoke podcast have been championing one particular design, the design and adaptation of something they did with some high school students in the States, and encouraging people to do just what I'm doing tonight, really, to encourage people to build a direct conversion receiver. But I'm not even going to ask that. I'm going to ask you, I wonder how many people have listened to single sideband on a direct conversion receiver. Because in these days of SDRs with brick wall digital filters, a direct conversion receiver, is going to sound different. I mean, it can sound wonderful because there's basically no filtering in the thing other than a bandpass filter, which, lets the entire 40 meter band through. There's no narrow filtering at all other than what's between your ears. And it can sound a right mess as well, because if it's a busy Saturday afternoon and there's a contest on, there's loads of signals there, there's all kinds of stuff. And it'll sound like different people are transmitting over one another, and it'll sound a real mess. There's a reason for that, right? So now, full disclosure, this next slide is the only slide of real dedicated RF theory. And to be honest with you, I love this stuff. I mean, this is why I build radios. I don't build radios because I need any more radios. I've got plenty of radios. I build radios so I can understand how they work. And when you build something yourself, you get a far more in-depth understanding because you probably built it and got it wrong and then got it working, and you learn so much. You learn just as much in the mistakes you make as, the successes you have. I'm going to tell you now how it works. So if this doesn't float your boat, then feel free to zone out for the next couple of minutes. But if you're interested in how a direct conversion receiver works, there's how it works. So we've got our product detector. Let's imagine we've got an RF signal coming into our mixer, our product detector, which is 3 kilohertz wide. Now, I know in practice it's probably not going to be 3 kilohertz wide, but it just makes the maths a bit easier. So, humour me. So let's say we've got a single sideband signal which is lying between 7097 and 7100 kilohertz, right? Now, we're going to mix that with our locally generated signal, our local oscillator, which is at 7100. Now this will give us, it will give us all kinds of stuff actually out the mixer, but primarily 2 main outputs, what we call the sum and the difference frequencies. So the sum is simply the RF over here with my ridiculously oversized pointer, plus the LO, and you'll see that gives us our original 40 meter signal translated to the middle of the 20 meter band. Now that ain't going to worry us because we're going to filter this out because we're not interested in the sum. What we're interested in is the difference frequency. So the difference frequency is the RF minus the LO. Now again, there's discussion about whether you take the RF from the LO or the LO from the RF. Well, mixers are clever, but they're not that clever. They don't know what they're supposed to be taking from one another. So my advice, and it's just simply that, I'm no expert, I'm just an amateur, but my advice is that you always start with the RF when you're doing this stuff. Always start with the RF, because if you do, you'll get some very, very useful information. And we can see that here. So, all right. So 7100 minus 7100 is 0 DC, that makes sense. But hang on a minute, look at this. 7097 minus 7100 is -3 kilohertz. You think, just a minute, how can you have -3 kilohertz? Well, you can't, of course, it doesn't exist. Except it does mathematically, but not in reality. There's only 3 kilohertz. So this is what actually happens. And they say a picture paints 1,000 words. So let me just show you this. So imagine, right? Okay, so we've got frequency down the bottom there on the x-axis. And what I need you to see here is, here's our single sideband, lower sideband signal lying between 7097 and 7100. Now, the height of this is not amplitude. Okay, what I need you to understand is the height of this is the frequency, increasing frequency of the modulated audio signal. So what I mean is, the thicker this bit is here, the higher in frequency. So this is the low frequency bit of the audio signal. This is the high. So immediately you see something very obvious, which is it's backwards, right? Because the higher you tune up through the 40 meter band, the lower in audio frequency you're going. And we know this, right? If it was an upper sideband signal, it'd be the right way round, okay? So it's inverted. That's not going to worry us, because of what we're going to do in just a moment. Okay, so there's our signal. Now, what happens when we mix it down? Well, mathematically is that, but as I said, that doesn't happen in reality, because it can't happen because there's no such thing as -3 kilohertz. What actually happens, are you ready? Watch that triangle here, right? What happens is it goes, right, whoa, and it folds around, we say, the DC mark. But look at this. Happy days. Look, now we've got what was our lower sideband signal. We've got the audio now the right way around, lying between 0 and 3. What could possibly be wrong with the world, you would ask? Well, just hang on a minute. Because sadly for us, 7097 to 7100 is not the only bit of bandwidth that is going to mix down to give us a signal between 0 and 3. If we had a signal, an upper sideband signal, lying between 7100 and 7103, that would mix down. And because it's in the upper sideband slot, there's no spectral inversion. That's what I'm saying. And that's what this minus means here. It means that it's inverted. There's no spectral inversion. So that would mix down right on top of it. But, Nick, you say, who's going to be working upper sideband on the middle of 40 metres? Well, probably no one. But probably what you will find, particularly if it's a busy contest weekend, there will be somebody else working lower sideband above your signal. But because this signal is lying in what would be the upper sideband slot, what happens is that mixes down with no inversion and mixes down as it is the wrong way round over the top of our signal. So when you listen, it sounds like you're trying to listen to a signal and some idiot is working upper sideband over the top of your signal, right? Now, you can't do anything about this. Blame physics. The only thing you can do is to change the format of your radio. So you could make it into a phasing radio where you get the I and the Q signals and you cancel the opposite sideband out. Or perhaps more commonly, you would convert it to a superhet. So you wouldn't mix it down to baseband. You'd mix it down to an intermediate frequency. And then you'd put it through a really narrow crystal filter that's only wide enough to let one of those sidebands through. And then when it comes to this process here, you ain't got to worry what's 3 kilohertz above it, because you've filtered all that stuff out, right? So you can mix it down to baseband with no worries at all. And that's how a superhet works. But so that's how it works. That's enough theory. So the challenge I set myself back actually in the autumn of 2022, is a little while ago now, was to build another direct conversion receiver. I've built a number of them. But this one, I decided, this time I was only going to use analog modules that I built myself and discrete components. So that means no Arduinos, no microcontrollers. Oh dear, that means, no SI 53, 51 phase lock loop signal generators, no LCD screen, none of that stuff. And not even any ICs, right? It's all got to be individual transistors and things, right? So now that's yeah, that was a bit of a challenge, but I thought, yeah, I'm going to try and do this. Okay. So now I'm a home brewer, which means I build things from scratch. So I have designed my own PCBs and sent them off to a fab house in China and got them done. Very, very rarely. Most of the time, I will build my own boards. Now, actually, fortuitously, and this, I wish I could say this was by design, but it wasn't. The 4 modules I'm going to show you tonight are actually all built with a different homebrew design technique. And this first one you will perhaps recognise as what's known as the Manhattan technique. Now, this is an older filter in truth, and generally speaking, I tend to use little me pads or me squares, they're called, which are little already kind of metal things. You can snap them off and glue them down, and actually they've got a little bit of solder on already, and you can make a neater job of it. Here you'll see I just cut up some bits of some copper clad board and glued them on. So now I'm not going to show you the schematic for this, because if you're interested, just go to Hans Sommer's QRP Labs website and look on his filters page. Hans is absolutely brilliant. The first radio I ever built myself, I bought one of his filter kits and built it, and I would advise you to do that if you've never done that before. His stuff is brilliant, and his instructions are so good, I'm afraid to say it's the only filter I ever bought from him, because I homebrewed all my own to his instructions ever since. So he kind of missed out a bit with me then, but I do try and give him a plug, because the stuff he does is fantastic. Now, this is the classic double tuned circuit. And now bandpass filters are not, I've started with this, but these are not the easiest things to build. Unlike low pass filters, where you can just, plug the values in, you get these fixed amounts of capacitance and inductance, and you put them in and you've got a fair to middling chance that it will work just fine. Not so with bandpass filters. They need a lot more tweaking. And essentially what you've got is, these are transformers actually, because there's a little kind of linkage winding which connects to give a bit more of a 50 ohms impedance match on the inputs and the outputs. And then these variable capacitors here. So these are tuned circuits, parallel tuned circuits. And basically what you're doing is you've got these 2 tuned circuits, and you're combining them. And you combine them by some capacitance in the middle, this coupling capacitor in the middle. And I find it's enormously helpful if you can have some variability here, and here. Because with the best will in the world, you're going to have stray capacitance, and your inductors are not going to be exactly what you thought they were going to be. So you need to be able to move it around a little bit to get the classic filter shape, which, is that kind of nice flat top, and then the skirts come down. If you've got a really sharp peak and lots of insertion loss, then that usually means that your filter is undercoupled, which means you need more capacitance on this coupling capacitor here. If you've got the classic twin peaks, the 2 humps of the camel, that's overcoupling, means you've got too much capacitance linking those 2 tuned circuits, so you need to reduce the capacitance here. But it's like all these things, the first time you build one, it will take you forever faffing around with it, trying to get it to work. But once you've done it once, the second one's not half so difficult, and then you kind of get into it. But you can get some very, very good results with this. So, but anyway, if it's a step too far at first, by all means, go to Hans's website and buy a kit for that one, and build your own next time or something. So, but that's the bandpass filter. So that will just allow our 40 meter signals to come from the antenna and pass through to the mixer, to the product detector. Now, the product detector is next. So what did I do with this? Well, I had a few goes at a few different designs, actually. So first of all, I thought, well, I found a design by my friend Pete Giuliano, N6QW, also of Solder Smoke fame. And some time ago, he created a design which kind of simulates a dual gate MOSFET. Now, dual gate MOSFETs used to be very ubiquitous, that you'd find them everywhere. They're not exactly unobtainium these days. I think you can get them in surface mount form, but they're nowhere near as common as they used to be. Anyway, Pete designed a way of stringing two J310 FETs together as if it were one dual gate MOSFET. And you'll see there's a transformer here just to do some impedance matching. And there's a filter, an audio filter here, so we're just getting the audio out to make sure we shunt the RF to ground, and the 1 millihenry choke here, just letting the audio, the low frequency audio signals through. And so I built this, and there it is. And it worked very well. But, you knew there was a but coming, didn't you? I was finding, when I put all this together with the other stages, and I was tuning around on 40 meters, I was getting a lot of AM breakthrough. As we know, in Europe, there are some very beefy broadcast AM stations just to the north of the 40 meter amateur band, and I was Radio China International. I tell you, I was hearing Radio China International all over the 40 meter band, right from the CW section, right through the FT8 bits, right into the sideband. You know, it was everywhere. It's just such a powerful signal. And actually, when I did some research on this, I realised that for as long as people had been using dual gate MOSFETs as product detectors, people were moaning about AM breakthrough, right? So I don't know whether it's just an inherent flaw in the design, and so you could probably use it on another band or maybe in another part of the world, and it would be fine. But for where I am in the UK, at 40 meters, I'm struggling with this thing. It works, but I am getting the AM breakthrough. So I thought, wow, what can I do about it? Well, I could go back to me tried and trusted double balanced diode ring mixer, and you'll see a photograph of mine here. Now I'm calling it second and third attempts because I did a couple of things here. Now ignore all this stuff at the bottom at the minute. So basically what you've got here, you've got these two balance, they are T1 and T2, which take the unbalanced signal in and give you a balanced signal then, which goes into the 4 diodes in the ring, which chops up the signal basically. And so I built just the vanilla diode ring mixer, and it was certainly a lot better. So the AM breakthrough was not as bad, but I was still getting some. And I mentioned this to corresponding with Bill Mara, and he said, Nick, have you tried the Roy Llewellyn W7EL audio diplexer? And I'd heard about this, but I hadn't tried that. And so Roy Llewellyn of antenna modelling fame, one of the other things he came up with was this little circuit. It's only about 4 components here, which makes sure the IF port sees a good 50 ohms termination. Now, I built RF diplexers in transceivers before on my mixers, but I'd never really thought, because I thought, well, it's the audio port. I mean, does that really need to see 50 ohms? Well, turns out, yeah, it does. And this little simple circuit, because it's got a 51 ohm resistor here, ensures that this port sees a 50 ohms termination much better than before. So I tried that, and that made a terrific difference, and the AM breakthrough was gone. So that was well worth doing. Now I'm going to show you now some test results. First of all, that's it. So Yeah, so here's the two balance. Here's my diode ring, and this is a little audio diplexer circuit here, very very small, and you'll see this. These are the me squares I was talking about before. So this is another Manhattan build here, and these are very useful because they're already tinned as well. So yeah, they're very good, really. Right. So let me show you some test results. So now let me just explain what I'm doing here. Now, obviously, this is a product detector, so I'm taking an RF signal in, mixing it with another RF signal, and taking an audio signal out. But the way I like to test all my mixers, whether I'm using them as product detectors or as balance modulators, is to actually test them as a balance modulator. The other way round, if you like, because that means I can get far greater accuracy in measurement at the RF frequencies because I can stick them onto my spectrum analyzer, which this is a screen grab of my spectrum analyzer. And so what I'm looking for is carrier suppression. So now I tested this actually at 13.3 megahertz, which was the IF of radio I was building. Don't get me into why it's 13.3. That's another talk. And so you'll see here, I've got the lower and the upper sideband, and you'll see here the carrier. Now, that's not, what's that, nearly 33 dB carrier suppression? I mean, that's not bad. It's not bad. But I think, well, I'd like to get this down a bit more in the weeds, you know, and get really good carrier suppression, because I know if I can use it well as a balance modulator, it's going to absolutely ace it the other way round, because, you know, these things work both way round. So okay. So now I know what some of you are thinking. Well, it's your shoddy workmanship, Nick. You know, if you built a better mixer, you'd get better carrier suppression. Why don't you use a professional one? Okay, a commercial one. Like this, you mean? Let me show you that again. So this is mine. This is my homebrew one, right? Look carefully at that middle one here. Number one. Look at this. This is, I shan't declare who it's manufactured by. This is a commercial one, passive diode ring mixer. Worse. By at least 10 dB worse, right? So it's clearly not that I've just built a duffer, right? There's something more going on. Now, this next one you're not going to believe, okay? So that the next display you're going to see is that same vanilla diode ring mix and the homebrew one I did with the Roy Llewellyn audio diplexer on. Look at this. Wow. Yeah? Carrier? What carrier? I mean, folks, it literally does not get any better than that, right? I mean, that's about as good as you're ever going to get, right? Superb. So that's the difference it makes. And so when I used that homebrew diode ring double balance mixer with the Roy Llewellyn diplexer as a product detector, the AM's gone, right? So yeah, works really well, and was very pleased with that. Right, okay, onto the audio amplifier. So I had loads of choices, really, because there's lots of audio amps that use discrete components. So this was one which appeared in the hallowed pages of Sprat, the official publication of the GQRP Club, which I'm proud to be a member of. And this was designed by Dieter Genzo, W8DIZ. And you'll see basically he's got a complementary pair here and here working as a kind of push-pull. So he's got a kind of driver section and a kind of higher power section. And that was it. Ignore that transformer. That was out of circuit. It was something I was trying, but I didn't use it in the end. And that worked well, actually. It wasn't the most powerful, but it certainly worked well. And again, corresponding with Pete Giuliano, he said, Nick, have you tried swapping out that last set of transistors, that last 2N3904 and 2N3906, and put in some dedicated audio transistors? He says, I did it once, makes an amazing difference. So this is the one that Pete designed. And essentially, what he suggested doing was replacing them with a TIP 31C and a TIP M032C, so NPN and PNP. But these are audio power transistors, so they're built to put out a bit more juice. And so I did. He said, don't bother, changing the biasing or anything. Just pull those suckers out, put these new ones in. And I did, and that had great results with that. And this is this one here, so you can see the two here. And because I wasn't even putting much, I didn't bother heat sinking them because I wasn't putting very much in. But it certainly gives you louder audio, which was ample actually for listening on the direct conversion receiver. So that was very good. Now, the oscillator, and to be honest, this was the thing. This was the project that started all this off, because in truth, I wasn't going to build another direct conversion receiver at this point in my life, but I was so taken by this, I just had to put everything down and go and do it. It's one of those moments you think, this is just too cool, I've just got to explore it. So, what's it about? Well, what sparked this off was Asher Farhan, that, one of the world's greatest home brewers, undoubtedly the creator of the micro BitX. Asher Farhan VU2ESE posted on his website 2 new schematics that just appeared. One was for his S-BitX, which was his software-defined radio, and the other couldn't have been more different. It was the complete opposite end, which was what he called his Daylight Again transceiver. And it was a transceiver which used all analog, all discrete components, right? Like I'm doing with this direct conversion receiver. But what was most interesting is it didn't use a variable capacitor in like a Colpitts oscillator or anything like that. It actually used a permeability tuned oscillator. So what on earth is that? Well, it's like a variable inductor, basically. And so instead of in a conventional analog VFO where you'd have a fixed amount of inductance and then you'd have a thundering big variable capacitor and you'd vary the capacitance, the problem with those things, of course, is that it's very difficult to build one which is frequency stable, because they tend to drift. And yes, it can be done, and I'm not disputing that, but it's hard, right? Whereas to do it the other way around, it seems much more forgiving to have a fixed amount of capacitance and vary the inductance. Now, Farhan used what he called a permeability tuned oscillator. What he in fact had, he 3D printed a little plastic former, and I think actually Bill and Dean from Solder Smoke have used the same design in their the Solder Smoke direct conversion receiver. And basically on the former, you wind your inductor on the former, and then there's a brass screw that you screw in and out of the coil. Basically, you've got a plastic former with the metal coil on the brass. Now, as people have pointed out, technically that isn't a permeability tuned oscillator, because brass has the same permeability as air. So you're not actually changing the permeability. You are changing the inductance, and that's what does the tuning. And I thought, well, this sounded great, but I don't have a 3D printer. I thought, well, I could get someone to print one for me. But because it wasn't quite so easily at hand, I parked it for a while. Until, I'm name dropping Bill Maher a lot tonight. I'm not on commission for Solder Smoke or anything. But he posted something on the Solder Smoke's blog about something he'd forgotten about some bloke that had contacted him years ago who'd actually built a genuine permeability tuned oscillator on a glue stick. In fact, this guy he'd used lipstick things and I thought, wow, on a glue stick. So with that, I stopped everything and bought a box from Amazon. And here they are. Now, you know the kind of thing I'm talking about. So, yeah, it pops off. You've got the glue in. Obviously, you have to take the glue out. But the way that the glue comes up, like a lipstick or anything else, is you twist one end, and there's a shaft, a threaded shaft up the top with a little seat that goes on, and as you twist it, this little seat goes up the shaft and then goes down the shaft and pushes the glue higher. And what this bloke had done, he thought, well, what if I wound the coil around the outside of the shaft and put some toroids or something, glued some on the inside, and then that would genuinely change the permeability of it, and I could tune a radio like that. I thought, this is great. I've got to give this a go. So this is what I'm talking about. So here's my workbench. So I think this was the first prototype that I did. So you can see I've got a couple of cable ties here holding the coil in. It's tapped just as Farhan taps his. So I did the same kind of thing. I think it's tapped about a quarter of the way through. And yeah, you can see there. So what I ended up, I think these are FT, they're type 6, aren't they? I'm not sure whether they're 50s or 37s. They might be 50s, but they're type 6 yellow toroids, iron dust toroids. And I glued something peculiar about using the glue stick. You've got to get rid of the glue. You've got to put more glue in to glue the toroids. I had to shave a bit of the plastic off with a craft knife so that they would sit evenly, and so the shaft would go through the middle without snagging as well. And yeah, and the first one I did, I got way too much inductance actually, so I ended up taking some turns off and redesigning it a little bit. But I could get plenty. Now this was the first little drawing that I did, and I often do that. I'll show you this because, you know, I could show you lots of nice pretty pictures like I do on the videos, but this is the reality of homebrewing. This is what I do, because sometimes you want to actually see what things look like. Now you'll also notice I did break my own 2 rules here, and I blame Farhan because I copied this straight from him. This voltage regulator, technically that's an IC, so, but you know, shoot me, right? So that's the only thing that managed to sneak in there. So again, I did this, and I could tune, well, as you can see down here, the whole of the 40 meter band and then some. So that worked really well. I started off with random ones on the first one, and then I progressed to the type 6. And this is what it looks like. So I used a nice metal tin to give a bit of shielding, because the first one I designed, I think I designed a theremin, because you went near it and all the hand capacitance is woo, woo, you know, you could kind of tune from a distance. So I thought, well, it'd be good. So I tried to, it's hard to ground something when it's largely plastic, but anyway. And you can see the actual oscillator board here as well. And yeah, so that fitted into a little tin. And I put something up on my YouTube channel about it, and I thought, blimey heck, this video is getting so many hits. Where's all these hits coming from? And I hadn't realised that Jenny List from Hackaday had found it and had run an article on it. This is in the January of 2023. So all these people come from Hackaday looking at this thing, which was great. So yeah, a few people kind of discovered it. Now, okay, what does it sound like when you put all these stages together? Okay, well, you're going to find out. So you're going to hear what it sounds like to tune across the 40 meter band on a direct conversion receiver, and you'll see and hear me tuning with this glue stick PTO. And just watch out for the end, because I was so impressed with this thing. I had to try something. You're not going to believe this, right? We talk about frequency stability. Just check out this bit at the end. Hope you enjoy.
PPY, then it's P, son of turn 2. from TV0PPY. Yes, you're peaking about 5 and 7 Kelvin, about 5 and 7, but there is quite a lot of fading on the band now, of course. Thanks very much indeed for the nice report. It's quite an old station here, but we've got a fairly decent microphone on it, and I'm cheating a little bit. I've got a little bit of compression on as well, and we can adjust the equalisation on that as well, so hopefully it's matching my voice okay. We're currently running about 450 watts out from the linear. George X-ray calling. M0RBI, G4B, GX calling. M0RBI, Mexico 0, Radio Bravo, Italy. M0RBI, M0RBI, George 4 Bravo, George X-ray calling. Yeah, there's a mic 3 station, you're right down in the noise. Just managed to get the M3 bit, give me a longer call. Yeah, mic 3 Fox, Whiskey Uniform, you're not too strong, it's going to be a bit of a struggle, but very good morning to you. You're about a 4x4, 4x5 perhaps, but right down into the noise. So back to you, M3FWU I think it is, or Fox November Uniform, perhaps you could confirm. G4BGX, over.
Okay, so this was a bit of an experiment, but I just had to try it really. So I've got almost the same setup as you saw before. So got the PTO connected, drawing about 30 milliamps as usual, except that I've disconnected the speaker here, and you'll see I've got another audio cable connected into that audio output, and that, if I just follow it, ignoring all the graveyard of other projects going on here, going over here, and it comes into finally into this, and this is a little Behringer external audio interface, and that it connects via USB to my Mac, and get a load of this. Yeah, I'm decoding FT8 on a glue stick PTO. Unbelievable. And I'm going to do a screen capture now, so you'll see this in more detail, but I just had to try it, but absolutely amazing. So you can see on my Mac I'm running WSJTX, and I've also got a browser running down the bottom left, and I'm on the PSK Reporter website, and you can see I've got it set up to show all the messages I'm decoding. That's the best one, I think. Asiatic Russia, yeah, so that's a good old way away, but yeah, plenty of stations across Europe. And you'll see, I mean, look at that waterfall. I mean, of course there's some drift, and that's evidenced if you look at the right-hand column. You can see that same G0 signal. I'm decoding it, but there's a little bit of drift. I've got it at 1790, then I've got it at 1788, and in a minute you'll see it's 1787. But that's only 3 hertz. I mean, that's quite incredible, really. And, you know, would you use it to decode FT8. No, of course you wouldn't if you wanted to do FT8. There's far simpler ways to do it. Even if you wanted to take an analog route, you'd use a crystal oscillator or something. But I just do it just to make the point about how stable this thing actually is, that it will even decode it. Now, I'd let the PTO run for a little while so it was warmed up and it settled down, and it does settle down remarkably well. But you can see from the PSK reporter map down the bottom there that I am decoding FT8, and it's really quite remarkable that you can get that level of frequency stability with a variable inductor built on a glue stick. So, and it just kind of makes you realise that if you can do this, then really SSB shouldn't be too much trouble. But yeah, there it is. Who would have ever thought? Glue sticks, is there nothing they can't do?
So, well, thank you very much for tuning in this evening to Tonight at 8. And if you've enjoyed hearing about some of the homebrew projects that I do, then please do look me up on Facebook. On YouTube. So you can put that in, or just go onto YouTube and search for M0NTV, and you can keep up to date with all my home brewing adventures. But thank you very much, and I'd be happy to take any comments or questions.
Thank you very much, Nick. Wow, that is so inspirational. And I've seen that before, as you know, but I still find that quite magical at the end, especially of that video, to show what you really can do with a few components. I mean, what are we looking at? A few pounds worth of components, I guess?
Yeah.
Literally,
really,
and the sort of thing that a lot of people have got in their spares box. Anyway, I hope you've enjoyed that at home. And if you have got any questions or comments you'd like to share and haven't already done so, please do so now on either the YouTube chat or BATC messaging. And please don't forget to include your first name and call sign if you have one on every message. That helps me read that out with the messages. We have already got several people commenting. It was nice as well, before we go to those questions so far, Nick, as well, that you've credited lots of different people who've inspired you and given various ideas along the way. And in fact, on Tonight at 8, over the last 5 years nearly we're up to now, we've had Asha Farha, we've had Anne Summers, and we've had Pete Giuliano as well. So you're all from a really good community of ideas people as well, making stuff. Right, let's go to some of the questions. And we start with lots of comments, by the way, and compliments as well along the way. People saying they're really enjoying the talk. Andy Collins was the first one probably to comment, who says, Manhattan construction, I use a spot weld cutter, a tiny ring saw, around circa 8mm is said, with a little spring-loaded spike in the middle. I just cut through the copper layer of the PCB to leave islands, very easy. So that's, I mean, I must admit, I'll be honest, I had to look at what spot weld cutter was, because I thought, what's that got to do with it? But I looked it up, and if you look it up at home as well, you'll find out what that is. A nice little circular saw, basically, isn't it?
I've not tried that. I've seen that done, and you can get some very good, neat results with that. One form which I didn't kind of show on here, I mean, you'll see the audio board I did was built on PCB strip board. But when I'm designing on the copper clad board, rather than gluing little isolated pads on sometimes, what I've done is a kind of variation. I tend to call it the Dremel technique. So, I mean, other brands are available, where you basically engrave your own traces. So I would usually engrave, I usually go for kind of squares or whatever, but you can do whatever you want. The advantage of that is that you can get it small, you can get it neat, but you need to really do it thinking everything you're going to do on that board first. Because what I've realised is it's not very easy to do that once you've got components on the board. So, and actually what sometimes I'll find is that if I've engraved a board and I think, I forgot that, or I changed my mind, I want to add something to it, another capacitor, or something, then I'll I'll actually then glue a little me square on there. So some of my boards are a bit of kind of hybrid of them both. But it is great. I mean, Pete, actually, he's got a full tilt CNC machine, so he kind of programs it and it'll, do it all exactly as you want it. But yeah, there's lots of different ways you can do it. But it's essential. I mean, the advantage of the engraved thing as well is that in terms of the pitch of your components, if you're going to be really OCD about this, because you can actually, everything's on the same level. Whereas obviously when you're gluing pads, some are going up and some are going down, and some components will sit easier if it's flat, all equally flat, rather than if some are kind of got to go uphill to go onto a glued pad.
But there's lots of alternatives, you say. I mean, when I started, there was things like Veriboard or coming in. Stripboard is often called. Veriboard was a trade name for it. But there are lots of other techniques. And by the way, those little, I can't remember what you call them, the pads, you can get them from the back of the Sprat magazine, can't you?
You can. And one of the questions I wish I had £1 for every time I ask me is, where do I get these? And I say, all you've got to do is go into Google and search for Manhattan pads. If you just put the Manhattan pads or something, and you'll get a choice of different ones. I mean, the ones that come from Sprat, I think, come from Rex in the States. There are other ones as well that you, depending on where you are in the world and what's easiest to get. But there are a few, yes, yeah, and which is better. I mean, it's a lot easier than sawing up lots of little bits of FR4 or something.
Yeah, absolutely. Brilliant, thank you. Graham J. WNC says, now that's a thing, a hand close proximity tuned radio. That was when you were getting, as those of us old enough to remember what the theremin effect was, which was an instrument of its time, wasn't it? But
it certainly was.
It used the proximity of capacitance, your hand capacitance around it.
I think I've got it. Hang on. I think the first prototype. I know you can see this.
Oh, right.
That was the first prototype. So actually, the actual, you probably can't see, but the actual gubbins of the actual oscillator in there, but the coil was on the top, which I soon found out was not, because the minute I went anywhere near it, was like, woo, you just couldn't do it. So that's why the next one, I made sure the whole thing with the windings were in the actual case.
But a serious point though, Nick, as well, is that most conventional receivers, if we ignore the modern varicap and all of the digital ways of tuning, they have always been the variable capacitance, because that's normally the easiest part to adjust, isn't it? And apart from maybe setting up cores with the inductors in a radio set as you're setting it up, you normally always vary the capacitance and not the inductance. But you've found that really has improved performance, haven't you?
It has. Funnily enough, I mean, PTOs have been around for a long time. I think Collins used to use them in some of their radios. Certainly, if you think back to the old AM car radios, where you used to have to, press the... but that was all PTO operated as well, which was really because, I mean, because it needed to be fairly stable. Because if you're bouncing around in a car, you can't have a variable capacitor, because that's never going to stay on tune very well. But they found that the PTOs work very well, and certainly with the FT8 test and stuff. I mean, I have to say it took quite a while to actually get it onto frequency, but once it was there, amazing, really. So yes, so I found actually it's strange, isn't it? It just seems to be a lot more forgiving in terms of frequency drift to vary the inductance rather than the capacitance.
Yeah, thank you. Quite a lot of messages coming up here. M0RKM says, any idea of the total cost of this?
Not really. I mean, obviously I paid more because I bought a whole box of glue sticks from Amazon, which you wouldn't need to do. So if you were to buy an individual glue stick, well, that's not going to cost very much, is it? Probably the most expensive things in it would have been the J310 FETs, and they're not very expensive, really. Most of the other things are pretty... Yeah, I mean, obviously you've got to get the toroids, but again, you can buy them all over the place. Yeah, so I mean, I couldn't put not very much at all.
Under £10 probably, wouldn't it be? I should think looking at that.
I would say so. Yeah. And it largely depends on the size of your junk box. I mean, for me, I could build a million of these things over because I've just got so many. I've got a big stockpile of components I use a lot, which is why a lot of us in the homebrewing world tend to use these. So people say, why do you keep building things with 2N3904s? Well, just because they're cheap and they're easy, and lots of people all across the world will be able to get access to them. Whereas if we start using really more difficult to get hold of parts, then it tends to kind of cut people off.
And also, we're radio amateurs. We never throw anything away, do we?
No.
I mustn't say too much because my wife's just a few metres away from me here in the studio. Steve GM0HUU says, thanks for the presentation, Nick. You are a real credit to the homebrew community. And also adds, he says, I'm glued to my screen watching this. So
very nice, Steve. I like what you did.
It is nice, and it made me think: what have you found any use for these lumps of glue that you must have to remove from these sticks, assuming that you're not using them up first?
No, I confess I haven't really. My wife runs a brownie pack, so maybe I need to kind of get them gluing and sticking to use a few glue sticks up. But yeah. I just went. I knew I was going to be using a few because I knew I was going to be doing a whole load of experiments. I went and bought a whole box of them. But yeah, you can just go and buy one or two. It's not a big deal.
Yeah. I'm sorry. All I've got there is Drone Nut. So I don't know what your name is. I'm really sorry. That's your YouTube name. Search for mint tin Manhattan pads, and that comes up for a nice mint-sized tin. For this sort of project, and Manhattan board as well. So there's lots of ways of getting those things, aren't there?
Yes, these this one is a case in point. I buy these. I think I buy on eBay, Amazon, whatever, 20, 30 at a time. They're like the little kind of Altoid tins. I used to have some that were slightly deeper, and you could actually get a BNC on the end easily. These are not quite so much. So, and I've tended to go more to SMA connectors now, actually, and that they will easily accommodate an SMA connector or a 3.5mm jack.
And if you scrape the paint off, are they quite easy to solder?
Yes, they're not too bad. As long as there's like a little coating of enamel on them, really. So generally speaking, you have to kind of scrape that off. But I find that with a lot of things. I find that with a lot of SMA connectors, for instance. Actually, before I would solder one onto a board, I usually get the Stanley knife and just rough it up a bit, just so the solder will stick, because sometimes they're so shiny and lacquered, these things, that actually they don't make a very good electrical connection.
A little bit of flux, the old-fashioned sort of flux might help there as well. You started off this presentation by saying that this was a presentation without ICs. All right, you cheated a little bit with the voltage regulator at some point, but these are discrete components that a lot of us have got already in our junk boxes, basically. Are you against then using ICs? Are a lot of your designs and experimenting, with just discrete components, or do you like to use modules as well?
Not at all. This was a real challenge for me because I'm a digital. Well, I'm a hybrid guy, really. But when it comes to oscillators, I would always build a digital oscillator, and as usually everyone, even my first radio I ever built had an SI 5351 phase lock loop generator, and that needs a microcontroller to function it. So, and they're easy, and I could do them in my sleep now. But I think sometimes it's just good to challenge yourself. And I think why I like going back to basics and to analog sometimes is that the trouble is you get into the kind of black box syndrome again, and you think, well, I'm using it, but I don't really know how it's actually doing what it's doing. I'm doing what I'm told to do, and putting this in here and putting 5 volts in here, and this is ground, but I don't really know. And I suppose it goes back to why I build in the first place, because I want to try and understand. But you can't do it all in a day, and you have to pick your battles, I think. And so you have to be content for a while to think, well, maybe I don't understand exactly how this works. I know enough about it to use it. I'll come back to that, right? And I've done that with various things in my life, and with with the homebrew channel, I would do that. So I had a time when I was doing like a deep dive on filters. I had a time when I was doing a deep dive on mixers and different ways of doing it, and the difference it makes, like when you match the diodes and all that kind of stuff. But it's finding the time and interest to do these different things. So and so it just depends what else you've got going on. But from time to time, I like to just strip it right back down. I did a series not so long ago on building a simple transistor amplifier, an audio amplifier it was, and actually designing it. So I went back to first principles and designed it, and we got into small signal analysis and calculating the input and output impedance and to say, look, you can do it. and I think now you're not necessarily going to want to do that all the time, but I think there's something enormously empowering about understanding what all these bits you've put in actually do. And that's, for me, that's more exciting than actually building it. It's the fact that, I built it, but I know why I've put those bits in there, right? And I know what they're doing and why I'm getting the results I'm getting. And I think, again, to name drop Pete Giuliano, his famous phrase is, when you know stuff, you can do stuff. And that's so true. All these skills are transferable skills, and they're cumulative skills. So the more you learn, the more you can take that stuff and apply it to something else and bite off bigger projects. So you start small and you don't try and run before you can walk. You don't suddenly just get up one day and say, right, I'm going to build an SSB transceiver. You start small, and then gradually you try bigger things, and that's the joy of it, really.
It really has been inspirational, Nick, and I hadn't decided really to talk about this before, but I hope you don't mind me saying that you're not a professional electronic engineer with a career long in electronics and things. Just because you're inspiring other people with your enthusiasm, with your experimentation, do you mind sharing with everybody what your day job is?
Yeah, not at all. Well, my call sign is M0NTV, and the NTV stands for Nick the Vic, because I'm an ordained minister in the Methodist Church. So I've worked in the Methodist Church as minister for 30 years this year. So a bit long in the tooth now. But yeah, so
when did you get into this side of the hobby then?
I've always been interested in electronics and radio, and it's I've built crystal sets as a kid, now electronic kits, and I built lots of kits, and I'm not against building kits, by the way. Just because I scratch build things now, kits are brilliant, and you've got to hone your skills. So learning to read resistor color codes, learning to try and not solder the transistor the wrong way round. I've still not quite mastered that one, but all these different things, learning how to solder, all these things are essential building blocks, and you get great experience building kits. Now, kits will take you so far, but so it's all good. Anything that can get people working with these things, trying to understand what's going on, building in confidence, it's a great thing. But yeah, so I've picked it up and put it down for many years, really, and I think it was just at one stage in my life where I had a little bit more time, which I don't have now, but at that stage I had a little bit more time, and so I managed to kind of explore, this whole business of, well, maybe I should think about becoming a radio amateur, but I'd been doing some shortwave listening for some time before then, and I quickly discovered, as I became a radio amateur, that just talking to people on the radio wasn't enough for me. And I'm not saying that that's a bad thing. Some people, that's what they want to do, and that's great. And as we were saying before, David, we call amateur radio a hobby of 1,000 hobbies. There's so many different things you can explore. You'll never explore it all. But I quickly found just the joy in building stuff and working out how it works, really. Which so that's that's where I got here.
Fantastic. Thank you. You really have been inspirational. We've got people watching this live from all around the world, in the States, and in fact just joined us, Kevin, 9V1KM from Singapore. So there we are. So saying thank you very much indeed for this. Thank you very much indeed for tonight, Nick. And I'm sure that you're going to really inspire lots of people to give construction a go. And you never know what you can make with a glue stick or anything else lying around the house. Thanks very much.
Thank you. Thank you.
Thank you. And that does conclude this webinar, and our thanks again to Nick Wood, M0NTV, and thanks also to the team who put this webinar series together behind the scenes. Well, we hope you've enjoyed this Tonight at 8. Why not give us a thumbs up to like us on YouTube if you did. We hope that you'll be able to join us next time when we'll be looking at HAMSCI, Space Weather We Can Do Together, with Nathaniel Frizzell, W2NAF. The 2025 RSGB AGM is this Saturday, April the 12th at 10 AM and is being live streamed so that more people can watch and take part. Members have until Thursday to send in a written question in advance. In addition to the formal AGM business, there will be a review of 2024, announcements of awards and the results of the RSGB construction competition. At the end of the AGM, there'll also be a presentation about the RSGB strategy, where you'll also be able to interact and ask questions. For more details of the RSGB AGM, including details of how you can vote, send in a question and watch, please visit rsgb.org/AGM. And if you'd like to see details of future webinars or watch recordings of previous programs in this series, please visit us at rsgb.org/webinars, where you can also send us comments and feedback. And if you subscribe to the RSGB's YouTube channel, you'll be notified of all upcoming Tonight at 8 webinars, as well as other new videos and presentations from the Society on a wide range of amateur radio topics. Thanks for joining us this evening, and until next time, this is David G7URP signing off and clear. Bye-bye.